Welcome, MAT 130, our quantitative reasoning students, to the second edition of this textbook. I'm going to be adding these videos the next couple of weeks to the updated videos. And so today we're working with Anakin Skywalker, Lego Anakin Skywalker. I don't know if this is an accident, but you can see, I'll take his hair off. He's got his headset going on here and his Jedi things. Oh, he's a double-headed guy too. He's angry and happy. We want him to be happy because we're doing math. So there, he's happy. Okay, so we're working with lesson 1.1, and we're talking about percents. We're going to look at these four objectives in this lesson. First, we want to make sure you can do calculations involving percents and conversions, and then there's a nice little formula for percent increase and decrease, and then just solve some problems using percents, which is essentially what evaluating claims is doing, although it's really going the next step. We have to solve the percents and then compare the results to determine which is the better option. So I want to highlight one specific thing down here. We get the definition of a percent. So percent can be translated as per 100. Now, you all may know what that means, but we can be more specific because in the math world, the word per means divide. So what we're really saying here is a percent means a number divided by 100. That's what a percent is. Anytime you see that symbol, for example, if I give you this setup, 3%, what we mean is 3 divided by 100. That's what 3% means. So if we on the next page, on page 6, we see this using the fact that percent means per 100, write 84% and 9% as fractions with denominators of 1. Well, that means we're taking this example problem here and we're making the denominator of a fraction 100, and the numerator is the number that comes before the percent sign, whatever that number is, whether it's a fraction or a decimal or a whole number like in this case. So 3% as a fraction would be 3 over 100. 84% as a fraction would be 84 over 100. And 9% as a fraction, same thing, 9 over 100. That's all we mean by a percent. Notice, by the way, in these cases, we dropped the percent sign when we converted it to this fraction with the denominator by 100. This portion, this divide by 100, is what this symbol means. It's exactly what we're telling you to do. I think folks came up with this symbol and this talk of percent because it's sometimes it's more useful to talk about percentages than fractions. All right, so it's a very simple rule. Our author tells us to convert a percent to a fraction, drop the percent sign, and use the percent number as the numerator of a fraction whose denominator is 100. In other words, divide by 100. Okay, so question 2 says, well, let's just convert this percent to a fraction, and then we're going to go back to old school stuff that you learned in elementary school, maybe 2nd, 3rd, 4th. Maybe this is more like 5th grade. I don't know where they teach you fractions. And we're going to convert this 42% into a fraction. So 42 over 100, the fraction is done, but we're told lowest terms or simplified form. So we could actually write this with a smaller number for the numerator and a smaller number for the denominator and still have the same fraction. How do we know that? Well, then top and bottom are both divisible by 2. So if I divide 42 by 2, I get 21. If I divide 100 by 2, I get 50. There's another way we could write this. Instead of thinking about dividing this, we could write these as their common factors. So we could say that 42 is really 2 times 3 times 7. 2 times 3 is 6. 6 times 7, 42. And 100 is really, well, let's see, 2 times 5 times 5, and there's also another 2 in here, right? 2 times 2 is 4, times 5 is 20, times 5 is 100. Then we can note that there's a common factor between the top and the bottom. So if we're dividing by the same number, we can divide that away, and that's equal to 1. 2 divided by 2 is 1. 1 times anything is that thing. So what we're left with here is 3 times 7 over 2 times 5 times 5, or written in another way, if we multiply those numbers out, 21 over 50. Okay, it turns out we can actually do all of this in a calculator. And in my opinion, if we can let a calculator do the work for us, let's do the work. So I've gone to Desmos.com. Here's that, DESMOS, and I've selected the graphing calculator because that's what we're going to use in Unit 2. You could certainly go in here under Math Tools and just get a scientific calculator that looks like this, and it will do everything we need to do for Unit 1. But you might as well get comfortable, I think, working in this, this graphing place because this is what we're going to use in Unit 2. All right, so what we wanted to do was take that 42%, we wanted to divide it by 100 and convert it into a fraction. Now notice the default in Desmos is to give us a decimal. But if we click this little button over here, bam, there's our fraction, and it's automatically in lowest terms. So for me, now other instructors may disagree, and that's fine. They're right. They could be right too. But for me, being able to get this simplest form is the most important. So knowing how to use the technology to me is quite important. But I think it's also helpful to know this mess as well. All right, one more question here. And that is 37.5%. Write that as a fraction. Well, this particular fraction is called a mixed number. And mixed numbers are nasty little numbers. Because when you look at them, we just write 37 and then we put a fraction next to it. And if you've gotten through high school algebra, for example, you know that when you see things written next to each other, like 2 and x, that there's an understood operation in between the 2 and the x. It means multiply. So here we've got these two like separate numbers next to each other, and there's just this, there's nothing there, and we might think it means multiply, but it doesn't. It actually means add. So this is literally 37 plus 1/2. That's why when we read a mixed number, we say 37 and a half. By the way, notice these are percentages on this. So what we really need to do is add these two numbers together. Now, there's two ways to do this. You may know a little algorithmic way to do it, and that was multiply the whole number times the denominator, add it to the numerator. In other words, 37 times 2 plus 1, that happens to be 75. And then that becomes the numerator of this thing, and then the denominator is unchanged. So our number really becomes 75 over 2. That's one way to do it. The other way to do it is if we look at this fraction, and we can add together these two fractions. So you may know that any whole number has a denominator of 1. Any integer, for that matter, has a denominator of 1. Any number that you see, or letter that you see, that doesn't have a denominator written there, its denominator is 1. That's an understood thing in mathematics. And so if you didn't know that, you now know that. Well, if I want to add these two fractions together, I'm going to do this right over here. I need a common denominator. Well, this has a 2, this has a 1, so I can turn this one into having a denominator of 2 using multiplication. Oh, look at this. 2 times 37, that's 74 over 2, plus 1/2. 74 plus 1 is 75 over 2. Hey, that's the same thing we got over here. In fact, you can see where this shortcut came from. Multiply the denominator times the whole number portion, add to it the numerator of the fractional part. So that's because when we got the common denominator, you're going to end up multiplying the whole number part to get the same denominator. Okay, well, you may be thinking, hey, we've answered the question. We wrote this thing as a fraction. Ooh, you're wrong. All we have done is rewritten that mixed number as a fraction, it still has the percent sign next to it, right? We never divided by 100. So that's what we're going to do now. I'm going to rewrite this on a clean sheet of paper. So we took that 37 and 1/2% and we turned it into 75/2%. So now we apply the definition of percent, divide by 100, and we get 75/2 divided by 100. Well, that's a mess, right? If you take pre-calculus from us, or college algebra for that matter, you'll note that this is what's called a complex fraction. It's a fraction divided by a fraction. And you may recall from previous courses in high school or even in elementary school, this division sign really means, or we can replace any fraction bar with a division symbol. So I just took the top, 75/2, put a division sign, and then put the bottom. And then I'm going to apply an algorithm that says keep, change, flip. So when we're dividing by a fraction, it's the same thing as multiplying by its reciprocal. Okay, so it's the reciprocal of the divisor, the number we're dividing by, or the fraction we're dividing by. Well, there we go. We get 75/2 times 100. So this becomes 75/200. And there we've now finally done it. We've converted this fraction, or this fractional percent, into just a fraction. And now we just need to simplify that. Well, what number goes into the top and bottom? Here's a great question. How many quarters are in 75 cents? Hey, there's 3, right? There's my 3 fingers. How many quarters are in $2? Ooh, tough. Well, I know there's 4 quarters in $1, so if I double that, there's 8 quarters in $2. That means it's 3/8. That's the final simplified answer. In other words, we took 75 divided by 25, we got 3. We took 200 divided by 25, we got 8. Here's your final answer. Now, I spent a long time doing all that mess. And there's a lot of kind of algorithmic work you got to remember here. Hey, I did this right off the top of my head. Great for me, right? I teach math. I use math almost every day because I teach it. Well, guess what? You don't have to know all that mess. Take that 37 plus 1/2, type it into Desmos. There's that mess. Convert it to its fraction. Hey, there's the 75/2, but remember this is still a percent. So let's do 75/2 and divide it by 100. Shazam. Oh, wait a minute. That's our decimal. We wanted this as a fraction. Click the fraction button. There it is. So much faster. Now, we don't know how the calculator got that, so it might be nice to know what I did here, because we know how I got this. I showed it to you, right? I talked you through it. Could you repeat that? Yeah, probably. Why not just let the calculator do it for you?